Terraform data is a built-in Terraform resource, not an AWS resource. The mechanism stores a value in Terraform state and manages it with the same lifecycle engine used for real infrastructure. The outcome is that plain data can participate in the dependency graph as an addressable resource. Variables and locals can hold values, but they cannot generate lifecycle events on their own. The input argument writes a value directly into the resource instance state. Terraform exposes that stored value through the output attribute after apply. The outcome is stable typed storage inside the graph, which downstream resources can reference consistently. When the output value is unknown during planning, Terraform preserves the same type structure as the original input, so the dependent expressions remain valid. Triggers replace stores of value that Terraform monitors for change. The mechanism converts a change in that value into a replacement operation for the resource instance. The outcome is a reusable lifecycle signal that can trigger dependent actions in the graph. This allows Terraform to react to a logical change signal without creating or modifying real infrastructure. The lifecycle argument, replace triggered by, only accepts resource addresses. Terraform cannot trigger replacements directly from variables or locals because they do not produce graph actions. Terraform data solves that boundary by converting a value change into a resource lifecycle event. When the input value changes, Terraform plans an operation on the Terraform data address, which lifecycle rules can observe. Think of Terraform data as a translator. It takes a human change, such as a variable update, and converts it into machine language, which is a resource action that the lifecycle engine can detect. Before Terraform 1.4, engineers used no resource to host provisioners or lifecycle signals. The mechanism required the external node provider, which added unnecessary provider dependencies to the configuration. Terraform data replaces this pattern because it is built directly into Terraform core. The outcome is cleaner infrastructure graphs and fewer providers to install or maintain. Terraform data controls Terraform lifecycle behavior, but does not create external infrastructure. The mechanism operates entirely inside Terraform's dependency graph and state engine. The outcome is that resource can signal change events but cannot enforce or verify real-world condition. On a submarine, a status lamp only mattered if it was wired to the equipment it represented. A lamp with no physical circuit could glow green, while the machinery behind it had already failed. Terraform data is the lamp for Terraform's graph, not the machinery in AWS. Use Terraform data when the plain value must behave like a lifecycle event in the dependency graph. Use it to anchor provisioners or convert logical revision numbers into replacement triggers. Do not use it when you need external information, because that is the job of data sources. The outcome is a clear architectural split. Provider resources manage infrastructure. Data sources read infrastructure. And Terraform data manages lifecycle signals inside Terraform itself.